everyone, welcome to Abhi online classes. Today we shall discuss Lagrange's mean value theorem in the chapter differentiability. Its statement is, if a function f of x is continuous in the closed interval a comma b, and this function is differentiable in the open interval a comma b, that is x lies in between a and b, then there exists at least one means greater than or equal to 1. There may be one value of x or more than one value of x. Say c. C also must belongs to the open interval a comma b such that f dash c is equal to f of b minus f of a by b minus a. This is the statement for Lagrange's mean value theorem. Let us discuss about this statement. Suppose this is a curve. The end points of this curve are A and B. Suppose this is x-axis and this is y-axis. Already I have drawn here. Once again see here from this diagram. Suppose this is small a and the coordinates of capital A are a comma f of a, and at B the coordinates of capital B are b comma f of b. Now this is the chord joining A and B. Now what is the slope? This is the chord AB. Slope of chord AB is y2 minus y1 by x2 minus x1. That is f of b minus f of a. Consider this as x1 y1 and this as x2 y2. Slope we know the formula, y2 minus y1 by x2 minus x1. So therefore f of b minus f of a by x2 minus x1 means b minus a. That means in this Lagrange's mean value theorem, f of b minus f of a by b minus a means slope of the chord AB. This is the slope of chord AB. And what is f dash c is, in this interval there must exist at least one value of x, say c, at this point. This is a small c comma f of c. The coordinates, we call this point as a capital C. So the coordinates of capital C is a c comma f of c. At this point, this is the tangent. There exists a unique tangent. At any point in between a and b, there exists a unique tangent. This is the tangent at c. So slope of tangent at C is f dash c. So this is the slope of tangent. So on differentiating any curve, we'll get slope of tangent. So this is the differentiating, f dash c means on differentiating f of c, we are getting f dash of c. So this is the slope of tangent at C, and this is the slope of chord AB. So this is the tangent and this is the chord. These two are parallel. These two are parallel. When two lines are parallel, their slopes are equal. So that is why slope of tangent at C is equal to slope of chord joining A and B. These two slopes are equal and these two lines are parallel. That is the geometrical interpretation of Lagrange's mean value theorem. Lagrange's mean value theorem says that there is some point, say C belongs to the open interval. Between A and B only we should, that C lies. There is some point C belongs to the open interval A comma B such that tangent to the curve at C, this is the tangent at C, is parallel. This tangent is parallel to the chord joining the points. This is the chord. So these two are parallel. So that is the main geometrical interpretation of Lagrange's mean value theorem. And one more point we should remember is f is a continuous. This curve is a continuous in the closed interval. That means A is included and B is included as well as the points in between A and B also. So at all these points at A and B and all the points in between A and B, this function is continuous. But in case of differentiability, when we observe, this function is differentiable only at the points which are lying in between A and B. Only at the points x which are lying in between A and B. It is not differentiable at A. and it is also not differentiable at B, because capital A and capital B are the endpoints. There we can draw infinite number of tangents to this. So there must exist unique tangent, but at the endpoints there are existing infinite number of tangents. So that is why f is not differentiable at A and B. That is the main observation we should observe. Then there exists at least one value of x say c, which is also belongs to the open interval A and B, means there must exist more than one value of c or one value. So that satisfies f dash c is equal to f of b minus f of a by b minus a. One more point I would like to say. In the last lesson we have discussed Rolle's theorem. In the Rolle's theorem we have the third condition, no? There f of b equal to f of a. That condition also must satisfy in Rolle's theorem. If we take this condition in this theorem, if f of b is equal to f of a, suppose we put f of b in place of f of b, f of a, plus f of a and minus f of a will get cancel, and we get f dash c is equal to 0. That means the slope of tangent is 0. So this Lagrange's mean value theorem converts to the Rolle's theorem only if you take this condition. But in the Rolle's theorem this condition is not satisfied. F of b is not equal to f of a. In the Rolle's theorem only it holds good. That is also we must observe. There also the function is continuous. In the Rolle's theorem also f is continuous in the closed interval, derivable in the open interval. There the slope of tangent, there the curve maybe suppose like this. Suppose like this. There slope of tangent at the end points there will be infinite number of tangents. At particular c, which is belongs to the interval closed interval a, open interval a comma b, at this particular point slope of tangent f dash c equal to 0. Slope of tangent is 0. That means there tangent is parallel to x-axis. In Rolle's theorem the main observation is tangent is parallel to x-axis. But in the Lagrange's mean value theorem, chord is parallel to the tangent at c. Chord is parallel to the tangent at c in the Lagrange's mean value theorem. But in case of Rolle's theorem, tangent is always parallel to x-axis. Slope is 0 there. Slope of tangent at c is 0. That is the main important difference in Lagrange's mean value theorem as well as Rolle's mean value theorem. Now we will see some problems. First we will see first problem. Verify Lagrange's mean value theorem for the function f maps from closed interval -1 to +1 to R real number line, real number set, given by f of x is equal to x cube. Here given f of x is equal to x cube. This is a polynomial function and we know every polynomial function is continuous. It is continuous. In the closed interval, here the interval is -1 to +1 and derivable also. In the open interval -1 to +1, f dash x is 3x square here. So it is continuous in the closed interval as well as it is derivable in the open interval. And both the conditions of Lagrange's mean value theorem are satisfied. Therefore, by Lagrange's mean value theorem, there exists at least one value of x, say c belongs to open interval a comma b, such that f dash c is equal to f of b minus f of a by b minus a. F dash of c is equal to 3c square. This is 3c square. In this interval, this is a and this is b. B is 1, no? So f of 1 minus f of -1 by 1 minus -1. So we got 3c square is equal to f of 1 minus f of -1 by minus into minus +1 +1 2. Now we find out f of 1. F of 1 is equal to 1 cube, that is 1. we find out f of minus 1. F of minus 1 is equal to minus 1 whole cube, that is minus 1. So this is f of 1 is 1, f of minus 1 is minus 1. So therefore 3c square is equal to 1 plus 1, that is 2 by 2, that is 1. 3c square is equal to 1. Therefore c square is equal to 1 by 3, which implies c is equal to plus or minus 1 by root 3. That is approximately, this is plus or minus 0.577. Definitely this c belongs to both the c values. We are getting more than one value, that is plus 0.57 and minus 0.577. Both the c values belongs to the open interval minus 1 to plus 1. So actually we used to get one value, but in this problem we are getting more than one value. Both these values are lying in this open interval. Therefore Lagrange's mean value theorem is verified. Now we shall see second problem. Let f maps from closed interval 0, 1 to R be defined by f of x is equal to x minus 1 whole square plus 2 for all x belongs to the closed interval 0, 1. Find the equation of tangent to the graph of this curve which is parallel to the chord joining the points A 0, 3 and B 1, 2 of this curve. For sample I have drawn here, but when we observe these points, in this point x coordinate is 0. Therefore that point must lie on the y-axis. That point must lie on the y-axis. So A 0, 3 and this is B 1, 2 and this is the curve and these two are the end points of this curve. We have to find the equation of tangent, that is at C we must draw a tangent, unique tangent. This is the tangent and this is the chord joining these 2 points. This is chord and this is the tangent. At C we have to find out now C. So by using Lagrange's mean value theorem, we find out C first. Given f of x is equal to x minus 1 whole square plus 2 for all x belongs to the closed interval 0, 1. This is a polynomial function. Therefore, obviously it is continuous and differentiable, derivable, or you can call it is continuous in the closed interval and it is derivable in the open interval. So already we have discussed earlier during the geometrical interpretation, at the end points we can draw infinite number of tangents. That is why it is not differentiable at the end points. So it is differentiable only in the open interval. Therefore, by Lagrange's mean value theorem, there exists at least one value of x, say c, belongs to the open interval. Here the interval is 0 to 1. So open interval 0 to 1 such that f dash c is equal to f of b minus f of a by b minus a. We find out first f dash of x. We have f of x is equal to x minus 1 whole square plus 2. On differentiating both sides, f dash x is equal to 2 into x minus 1 plus 0. Therefore, f dash c is equal to 2 into c minus 1. Now we replace here 2 into c minus 1. F of, in this interval, this is a and this is b. b 1 and a is 0. 2 into c minus 1 is equal to f of 1 minus f of 0 by 1 minus 0. 2 into c minus 1 is equal to f of 1 we prepare. F of 1. 1 minus 1 whole square plus 2. 1 minus 1 anyhow cancel. Therefore f of 1 is 2. F of 0 also we must find out. F of 0 is equal to 0 minus 1 whole square plus 2. That means minus 1 whole square plus 2. 1 plus 2, 3. So we got f of 0, 3. This implies 2 into c minus 1 is equal to minus 1. C minus 1 is equal to minus 1 by 2. We got C is equal to minus 1 by 2 plus 1. C is equal to 1 by 2. So we have now C is equal to 1 by 2. Now we prepare C 1 by 2 x coordinate. Then what is the y coordinate of this particular point? We call this as capital C. That particular point we call it as capital C. And now small c we got is 1 by 2. This is capital C. This is also same. So capital C we prepare. X coordinate is 1 by 2. Now y coordinate is f of c. So how to find f of c means put c is equal to 1 by 2 here. F of c we prepare now. Therefore, C 1 by 2 comma 9 by 4. So we have prepared C. That point we call it as x1, y1. Our target is to find out equation of tangent. Equation of tangent, we already know equation of line when it is having a point and a slope. So then the equation of tangent is y minus y1 is equal to m into x minus x1. Just now we have found out x1 is 1 by 2, y1 is 9 by 4. These are the coordinates of C. So x1 1 by 2, y1 9 by 4. Now we have to find out m, slope of tangent, that is f dash of C. Now our target. So already we have discussed f dash of C is the slope of tangent at C 1 by 2 comma 9 by 4. So slope of tangent means m. F dash of C, earlier we have seen this is 2 into C minus 1. This is equal to m. So therefore now we put C 1 by 2 here also. Therefore m is equal to 2 into 1 by 2 minus 1 is minus 1 by 2. Cancel 2. Therefore slope of tangent is minus 1. Just now we have found out C x1 y1 1 by 2 comma 9 by 4, and we also have a slope of tangent. Therefore equation of tangent at C 1 by 2 comma 9 by 4 and slope m minus 1 is y minus y1 equal to m into x minus x1. This is x1 and this is y1. Y minus 9 by 4 is equal to m minus 1. X minus 1 by 2. Now taking LCM, 4y minus 9 by 4 equal to minus 1 into 2x minus 1 by 2. Cancel 2 times. Now cross multiply. 4y minus 9 is equal to minus 2 into 2x minus 1. 4y minus 9 is equal to minus 4x plus 2. Therefore minus 4x we bring this left side. 4x plus 4y plus 2 also we bring to the left side. Minus 2 minus 9 minus 11. This is the equation of tangent at C. So like this, by using the Lagrange's theorem, we have found out equation of tangent at C. Hope you understood this class. I have taken a different problem, not only verifying Rolle's theorem, verify Lagrange's theorem. This type of questions may help you much more. So hope you understood. Thank you.